Welcome to Disasters Daily. Today we will be learning about Krakatoa 1883, an eruption that occurred in the Sunda Strait between Java and Sumatra in Indonesia. The 1883 of Krakatoa began in May 1883 and culminated with the destruction of Krakatoa on August 27, 1883. In the end, the eruption caused more than 36,000 deaths and even affected global temperatures. Today, we have Tristan here at SSU with an exclusive interview with Dr. Suryansh Kumar, world volcano scientist.
Thank you, Vincent. Now, ladies and gentlemen, we have a special guest with us today. He is a friend of mine and a very acknowledged scientist, Dr. Kumar. Now, he has done extensive research in the fields of natural disasters such as earthquakes, volcanoes, and tsunamis. Now, he has written many articles for the Science and Engineering magazines. He has written many good books, and he is here to share with us some of his knowledge. Now, here with us today is Dr. Kumar.
Hello, Tristan. It's my pleasure to be here.
So, Doctor, would you mind explaining to our viewers what plate tectonics are and how we are affected by it?
Tristan, that is a wonderful question. Plate tectonics is a scientific theory that involves large-scale motions of the Earth's lithosphere. The theory is based on the concepts of continental drift, which was developed at the beginning of the century, and is widely accepted now as the concept of seafloor spreading by a community of geologists. The lithosphere is broken up into many plates. In the case of the Earth, there are currently 7 or 8 major plates and many minor plates. Lithospheric plates ride on top of the asthenosphere. These plates move in relation to one another at 3 different plate boundaries. First, the convergent boundary, second, the divergent boundary, and last but not least, the transform boundary. A convergent boundary is where 2 or more lithospheric plates collide with each other. A divergent boundary is where 2 or more lithospheric plates move away from each other. A transform boundary is where 2 or more lithospheric plates slide past each other. Most of earthquakes, volcanic activity, mountain ranges, and oceanic trench formation occurs along these plate boundaries because of the movements of the plates. As an interesting fact, these plates actually move up to 100 millimeters annually.
Oh my God, up to 100 millimeters annually? This is some interesting fact, Dr. Kumar. But anyway, would you mind telling our viewers what plate tectonic conditions caused this 1883 disaster of Krakatoa?
Oh yeah, sure. Well, Indonesia has over 130 active volcanoes, the most of any nation. These islands make up the axis of Indonesian arc system. They were produced by the northeastward subduction of the Indo-Australian plate. A majority of these volcanoes lie along Indonesia's 2 largest islands, Java and Sumatra. Krakatoa is directly above the subduction zone of the Eurasian plate and the Indo-Australian plate, where plate boundaries make a sharp change of direction, possibly resulting in unusual weak crust in the region, and everybody knows what happens when crust is super weak.
So, Doctor, how badly was local life affected by this explosion?
Tristan, the local life was just devastated. The damage was so widespread. Over 165 towns and villages were destroyed and 132 severely damaged. More than 21,000 people had died and many were injured by the eruption and the tsunamis that followed the explosion. More than 2/3 of the island of Krakatoa was destroyed.
Oh my God, this is massive destruction that the poor Indonesians had to sadly withstand. So, Doctor, is there anything else you would like to tell the viewers about the 1883 Krakatoa explosion?
With a volcanic explosive index of 6, the explosion was equivalent to 200 megatons of TNT, which in comparison is 13,000 times stronger than the little boy bomb that devastated Hiroshima in World War II, and up to 4 times stronger than Tsar Mamba, the largest nuclear device ever detonated on the planet.
Dr. Kumar, it's been a pleasure to have you here. You've provided our viewers with excellent information and knowledge about plate tectonics and the 1883 Krakatoa disaster.
Anytime, Tristan.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption. The remarkable cycle is complete.
What a pleasure it was to have Dr. Kumar here. And now, I'm happy to introduce Austin, our graphic designer.
Thank you, Vincent. Hi, I'm Austin. We have created a montage of volcano eruptions to help demonstrate the Krakatoa explosion. Over the past 3 weeks, me and my team have researched and created a movie of volcano eruptions similar to the Krakatoa explosion.
Yeah, you know what it is. Crusted metal, crusted metal, crusted metal, crusted metal. Yeah, you know what it is. Crusted metal, crusted metal, crusted metal, crusted metal. Yeah, you know what it is. Crust moving cause of plate tectonics. Yeah, mantles like plastic, and the core is really dense and metallic. Memorize a song and you know everything about the crusted metal, crusted metal, crusted metal, crusted metal. Moving on down, there are two more layers called the outer core, inner core, outer core, inner core. Mr. Lee, science teacher at it again. Sick flow, spitting that regurgitation. Ready to begin, so without further ado, I'ma hop up on this fresh beat so I can teach you about the layers of the earth. First things first, the outermost layer is called the crust, filled with dirt and rocks and sand. I hope you understand. The crust is a layer on top of which we stand. It's made out of rocks, mostly igneous. Oceanic crust, the densest and the skinniest. Sinks below some other crust during subduction, which might result in a volcano and eruption. Yeah, you know what it is. Crust moving cause of plate tectonics. Yeah, mantles like plastic, and the core is really dense and metallic. Memorize a song and you know everything about the crusted metal, crusted metal, crusted metal, crusted metal. Moving on down, there are two more layers called the outer core, inner core, outer core, inner core. Go down to the ocean floor, you'll see that it is getting new rock by a process known as sea floor spreading. The continents fit together, something like a puzzle. They're moving so slow like a center in the huddle. Used to be a supercontinent, Pangea. Then they moved apart, continental drift, see ya. Since they're always moving, there's a great amount of stress. Tension, compression, and shearing will be on the test. Yeah, you know what it is. Crust moving cause of plate tectonics. Yeah, mantles like plastic, and the core is really dense and metallic. Memorize a song and you know everything about the crusted metal, crusted metal, crusted metal, crusted metal. Moving on down, there are two more layers called the outer core, inner core, outer core, inner core. When the rock breaks, there's a crack called a fault. Usually plates are locked up like a vault, but when the stress builds up, the pressure's too great. The ground starts shaking because of an earthquake. Why do plates move? I hope you heard the lesson when I said it's from the heating of the mantle by convection. The track's running out, the only thing missing. The inner core is solid and the outer core is liquid. Yeah, you know what it is. Yeah, you know what it is. Memorize a song and you know everything about the crust and mantle, crust and mantle, crust and mantle, crust and mantle. Moving on down, there are two more layers called the outer core, inner core, outer core, inner core. Yeah, you know what it is. Crust moving cause of plate tectonics. Yeah, mantle's like plastic, and the core is really dense and metallic. Memorize a song and you know everything about the crust and mantle, crust and mantle, crust and mantle, crust and mantle. Moving on down, there are two more layers called the outer core, inner core, outer core, inner core.